In this lab, we will be investigating the reaction involving the dehydration of copper 2 carbonate hydroxide hydrate by heating the substance. Since this reaction involves heating, a crucible and Bunsen burner will both be necessary for the reaction to occur. We will also need a balance to record the mass of the crucible and its contents before and after the reaction.
We will add 5 grams of copper carbonate hydroxide hydrate to the crucible and take the mass of the crucible and substance so that following our reaction, we can calculate the difference in mass to determine how many water molecules evaporated. This will allow us to calculate the hydration of copper carbonate hydroxide hydrate.
After taking the mass of the crucible and its contents, we place the crucible on top of the Bunsen burner. In order to observe the reaction, we will click Show Contents in the Properties menu of the crucible.
Once this is set, we turn the Bunsen burner onto low flame by clicking the heating knob once and zoom in to watch the reaction to occur. This reaction will take about 1 to 2 minutes.
As we observe the reaction, there is a sudden change in color from a green compound to a black compound, indicating that the reaction has completed and the copper 2 carbonate hydroxide hydrate has been dehydrated. Upon observing this change in color, remove the crucible from the Bunsen burner and set it on the table to allow it to cool. After setting down the crucible, turn off the Bunsen burner.
Once the crucible has cooled, place the container on a balance to record the new mass of the crucible and its contents. The change in mass indicates the evaporation of water molecules in the compound as they turned into gas during the reaction.
This is a decomposition reaction as it involves the separation of copper 2 carbonate hydroxide hydrate into water molecules in gas form and copper carbonate hydroxide in solid state. The chemical equation for this formula can be seen on the screen as we use the mass of the remaining copper 2 carbonate hydroxide and the mass of the evaporated water molecules to calculate the coefficients in the chemical equation.
Therefore, the balanced chemical equation reads 1 mole of hydrated copper carbonate hydroxide hydrate bonded with 6 moles of water when heated reacts to become 1 mole of anhydrous copper carbonate hydroxide, which is a solid, and 6 moles of water in a gaseous state.